This one script that we have built looked at 2000 customer accounts and told us exactly which accounts are about to churn. Together, those accounts represented $375,000 in monthly revenue that's at risk right now. In the next few minutes, I am going to show you exactly how this works line by line, and I promise you don't even need to know how to code to follow along. By the end of this, you will understand very well enough and be able to explain it to your team as well. So let's quickly get into it. Now, here's every good account manager already has a sixth sense where they are able to feel when an account is going sideways. What they observe is, say, the login have dropped off, the support tickets have piled up, your champion, say, or the person whom you are in touch with goes quiet for a few weeks. And the problem over here is that gut feeling, although that good, that accurate, might not be able to scale. It would work great for say 20-30 accounts that an account manager really knows well, but it falls apart as soon as they start managing a larger account base, say 200, 300 accounts on a monthly basis. So here's the core idea behind everything that we are going to build. One is what we are going to do is we are going to have a model created and we are going to show it a bunch of accounts that have already churned in the past. Now what it does is it studies the common patterns across these accounts and then it checks it with every current account and gives us those warning signals. That's it. That's the whole concept. Everything else is just making that happen with the help of this code. So let's quickly get to understand what the code is all about. Now first things first, this block right here that you can see, it's where we are importing multiple libraries. So it's not doing anything clever yet. What it's doing is just opening a toolkit. So what you can consider this to work as is like, say, think you are opening up an Excel or a calculator. Now, to quickly give you an overview of what we have over here is the libraries that say pandas over here that handles our data table. Then this particular library handles our actual machine learning engine. Then we have matplotlib and seaborn that build our charts. So let's quickly move on to understand what happens once these are imported. Now say, when we talk about the dataset, I don't have a real customer dataset at this point that I'm loading into it. So what I've done is I've generated 2000 fake but realistic customer accounts to practice on. So if you look at this table, each row is one account and each column is a signal we are tracking. Like how many seats are actually being used, how many times they are logged in over the last 30 days, their NPS score and other details. And the most important part over here is that all of these fields, right, these are actually there on multiple tools right now, like say your CRM, your product analytics tool, your customer support tool. And these fields are there, but they are just fragmented across these tools. So you're just not looking at them all together for every single account every single week. And that's the gap that we are trying to close. Now say before we trust this model, what we're going to do is we're going to do a quick sanity check on the raw data first. So we have these 4 charts that we have created that compare the churn accounts against the retain accounts side by side. So if you say look at the NPS score right over here, the churned accounts are more towards the negative side, the retained accounts are on the positive side. And the same story is with the active seat percentage, where on the top left we see that the churned accounts sit noticeably lower. Now this isn't the model working yet, this is just confirming before we start building anything on top of it that these signals actually mean something. So it's very important for us to always check this first. Now moving on, say we start with the preparation of the data, that's the feature design. 2 things happen over here in this step. One is we convert the text categories like say for example enterprise or SaaS into a number format that the model can actually read, because computers don't understand words, what they understand is numbers. And the second thing that we are doing, that's the most important part, is that we have split our 2000 accounts into 2 piles. One is a pile of 50 and 100 accounts to teach that model, and then there will be 500 accounts that we are hiding so that that can be used for testing. So what you can consider this as, say for example you are studying certain practice questions, and then when you are sitting in the exam you get those questions that you have never seen before, and that's exactly these 500 accounts that come in the exam. Now say for example we have these 2 models ready. So what we are going to do is that to have our complete model created, we are going to build 2 training models. So for this we are going to have that same data trained on 2 learning models and ensure that they compete to ensure which model works best. So first up we have logistic regression, wherein it has given us a score of 0.696. Now quick understanding of what this EUC is, basically it's a score out of say 1 that tells you how well a model separates will churn from won't churn. So a score of say 0.5 would be like a coin flip where it's pure guessing, but a score like this that is 0.696 is decent, not great though, but decent. Now next what we have done is we have used another model called as a random forest. Now you can think of this as say a committee of say 300 simpler models all voting together. Okay. And what it does, it scores it as 0.764, which is noticeably better than the earlier model. So why does this improvement come in? What is the difference between these two models? So random forest is say better at catching a combination of signals. For example, low logins on their own might not mean much, but low logins combined with no executive sponsor is a much stronger warning signal. And that's the kind of pattern that random forest catches than the simpler model that are there like logistic regression. Now, one important note over here is that this model won't be perfect. Some of the accounts it flags at high risk will turn out to be false alarm. And that's completely normal because what we are building is a prioritization tool and not say something that will give you a short that okay, no, this account is going to churn. Right? So now if we see what we have then done is to compare both of these models, we have visualized it through a chart. And this chart gives us that complete understanding that okay, how do these two models function. So you can see the orange random forest lines that sits above the logistic regression line almost entire way across. So this is a visual proof that it's a stronger model, and that's exactly why the AUC score for this is higher. Now say for example we move on to the next part, and in my opinion this is the single most useful part in the entire video. So let's quickly understand what this is about. So we have asked the model out of everything that they have looked at from the signals that we have provided, which signals actually matter most in terms of predicting the churn, and it has given us a ranked answer. Number one, say active seat percentage. By a wide margin, this was the strongest predictor. Then we have whether the account has an executive sponsor or not. On number three, we have the NPS score, and then so on. We have days since their last login and whether their contract value dropped at the last renewal or not. So here's why this matters is because say for example if you're an account manager and if you only have time to check one thing before the renewal call, this data is telling you check the active seat percentage and whether you actually have an executive sponsor in the room or not. So then it will ensure that okay, you don't obsess over say support ticket count, saying that okay, no, since they have higher support ticket, so they might churn. And considering that that is the least, and it is assumed as one of those parameters that is very important, right? So that is what we are trying to show here, that it helps you analyze which points matter more. And one thing to clarify here is that this isn't a guess, this isn't a hunch, this is a simple pattern recognition over the real accounts that we have trained the model on, right? Now moving from say the model to understanding where it actually gives an output for an account manager or for the sales team. So this is where it all stops being theoretical and starts being useful for us. So we take our say trained model and run it against every single account, not just say 500 that we tested on, but the entire 2000 accounts that we had in place, and give each one a risk score between 0 and 1. Then what we are doing is that we are sorting every single account in a risk tier like low risk, medium risk or high risk. And we rank the high risk accounts by their revenue size and the biggest first. So what we have as an output over here is those 235 accounts that have landed in the high risk tier. And together, as I mentioned earlier, they represent 375,000 of the revenue, monthly recurring revenue. And this table right here that you can see where it has the account ID, the monthly revenue, the segment, whether they have an executive sponsor or not, their risk score, all of the other details is what would land in your account manager's inbox every single morning. So it's not a code, not a chart that anyone is going to read, but it's a ranked call list sorted by what actually matters. Now, before I wrap up, there is a very important thing that I would want to share over here, that one, this model does not tell you why one specific account is at risk in a way that replaces actual, say, picking up the phone and talking to them. It's more of that pattern matching across thousands of accounts where it tells you where to look first. So it doesn't replace that entire relationship building part that account managers always focus on, but rather tells you that okay, what can be prioritized. Right? And to be fully transparent about what all can you achieve through this is one, see, this was a demo code, but you can integrate your CRM, your product user data and your support ticketing system as well into this. And you can have that entire model retrained periodically as your business evolves. So this was about it. This was about how you can actually use Python to build a churn prediction model. And if you found this useful, please do like and subscribe to our channel, and let me know in the comments if you would want me to model some other use cases, be it upselling opportunities or deal risk scoring, whatever that might be relevant to your use case, and I'll take that up. Thank you so much for watching this one. See you in the next one.